Today in the Universe Sandbox simulator, I'll flood the Moon and Mercury and show how water affects these worlds, how their surfaces change, and what they'll become. Let's go! We'll do the first experiment with the Moon. I've launched a water object at it containing a volume of water equal to 10% of all Earth's oceans. I purposely made the speed very low so that the Moon's surface wouldn't heat up from the impact. Moreover, as it flies, I'll slow the object down further because its speed is gradually increasing. And now this object has already begun its collision with the Moon. As we can see, the water is sweeping across the Moon's surface like a tsunami. I'll speed up time in the simulator and I won't forget to slow down the speed here. Oh, look at how many fragments are flying out right away. And we see a lot of water appearing on the Moon's surface. Then, well, great, the object has landed. There's no heating on the surface, it's just perfect. And here we see how the water behaves. So of course many particles were ejected into open space. I'll speed up time. Many of them will of course return to the Moon. Well, things went a bit off plan here. One fragment fell and heated up the Moon's surface right here. But oh well, as we can see, clouds and some kind of atmosphere are starting to form on the Moon. Right here at the impact site, a large ocean is simply spreading out. The temperature on the Moon is falling now. The situation is stabilizing after this impact. And we see that the atmosphere is getting denser and denser. And I'll show you the composition. The Moon's atmosphere is of course formed from water vapor, and there's a lot of water in the oceans. Time has passed, and basically I see that the temperature on the Moon has settled and varies from 26 to 27 degrees Celsius. Now I've hidden the atmosphere and clouds, so let's evaluate the surface of this satellite. As we see, the water is mostly here where the main impact was, as if there's a large crater here and it's been flooded with water. And over here there are a few lakes like this. I'll try to distribute this water evenly across the entire surface of the Moon. And this is how it turned out. And I'll also level out all the gases in the atmosphere. And as the simulator shows, the probability of life on such a moon is 1.5%, and the atmospheric pressure is 11/100ths of 1 atmosphere. So, what do you think of this lunar surface? Yes, life didn't form, but the Moon became more attractive and gained an atmosphere. Though without a magnetic field, over time all this atmosphere will simply fly off into space. But what if we pour 10 times more water onto the Moon? Now we'll do the same experiment, but this time the water object will contain 10 times more water, a volume equal to all Earth's oceans. And as we see, it's become quite large compared to the previous object, and matter like this is starting to break away from it. Most likely this water simply isn't being held in. Meanwhile, our collision has begun. I'll speed up time to 3 months per second, and we see that the temperature on the Moon has really started to rise. And look at how the water vapor has started to release. Wow, look at that. Intense things are starting to happen. I'll hide the atmosphere and clouds. Well, the water is even starting to evaporate due to high temperatures. See, it's already over 100 degrees Celsius here. We are now bringing back the atmosphere and clouds. It's really covering the Moon now. Let some time pass, then I'll show you the final result. Well, that's basically it. As for the temperature, it looks like it's stabilized. 139 degrees Celsius is the average temperature, but the atmospheric gases haven't leveled out yet. To avoid waiting, I'll spread all these gases evenly across the surface. And we see that such a thick atmosphere has formed on the Moon that the surface is completely hidden. We can only see the poles now, hiding the atmosphere and clouds. And we can see there's a lot of water here. If we try to spread the water evenly, you'll see it instantly starts evaporating from the equator because it's so hot there. Well, that'll just add even more water vapor to the atmosphere. Once again, 3 months are passing every second. I thought the water would evaporate faster, but as you can see, it hasn't. It seems like everything is actually stable now. So what do we have here? There's 120 times more water vapor in the atmosphere than one Earth atmosphere. Incredible. And because of that, the surface pressure on the Moon is over 25 atmospheres, and the sea level is 8.5 kilometers. The likelihood of life is just under 1%. Now it's clear why liquid water exists here on the Moon's equator, because the high pressure is able to hold it in place, and the temperature rise on the Moon is due to the fact that water vapor is a very potent greenhouse gas. And now our Moon is simply unrecognizable. There's our planet Earth in the background, showing you the Moon and its North Pole once again. At least you can see something there. Now I'm going to flood Mercury, the closest planet to the Sun. I've launched a water object at it with a volume equal to 30% of all Earth's oceans. Just like with the Moon, I've intentionally lowered its speed and will slow it down further as it moves. Well, here's a massive water wave sweeping across Mercury, a tsunami you could say, and as we see, gases are immediately released into the atmosphere. It's just that Mercury is a very hot planet. Naturally, the water will start boiling there immediately. You can't tell if Mercury has heated up or not, so I've hidden the atmosphere in clouds. Of course I managed to heat it up. Well, hopefully not too seriously. 1364 degrees Celsius. That's a bit off plan. Let's set it to around 500 degrees Celsius. I don't need to overheat Mercury. And I'll speed up the passage of time to 1 month per second. Looking at the surface, a crater has formed at the impact site and filled with liquid water. On the rest of Mercury, we see a few scattered small lakes just like these. Most likely debris falling back brought water here, but as you can see, all that water is just vanishing. And I assume this large ocean will also disappear in the same way. Well, we see that Mercury is actively starting to lose its matter. Just a massive amount of gas is escaping into space. Most likely this water vapor is being lost from the atmosphere because the star is so close and the lack of a magnetic field takes its toll. What if I tried to spread the gases evenly across the surface of Mercury? Well, here we have, just like with the Moon, a completely dense atmosphere covering the surface of this planet. I'll hide the atmosphere in clouds. And what if I also try to spread all the water evenly across Mercury's surface? Well, everything collects back into this large crater at the impact site, and we can see water ended up at the poles too. There's no water in this part, but the atmosphere is still slowly leaking away into space. In the end, the average temperature on Mercury settled at 380 degrees Celsius. We see there's no water at the equator at all, and water only remains at the poles. Here's the North Pole, and here's the South Pole. If we show the atmosphere and clouds, we'll see this dense atmosphere made of water vapor. But there's so much water vapor in the atmosphere that the surface pressure on Mercury is 149 atmospheres. That's more than on Venus. Well, because of that, the temperature became much higher than Mercury's was before. As you can see, this amount of water literally turned Mercury into a giant hot steam bath with a dense water vapor atmosphere. But this atmosphere is being actively blown away by the solar wind because Mercury has no magnetic field to hold it in place. So I'll run another experiment. This time, I've launched a water object containing only 5% of the volume of all Earth's oceans. That is, it has 6 times less water than in the previous experiment. The object has almost crashed, slowing down its speed. Still, look at how incredibly hot Mercury already was to begin with, so there's no way to avoid this glowing heat. Mercury still ends up glowing hot. A full month passes by every second, and water vapor instantly appeared at the site of the impact. And it seems like the atmosphere might not be quite as dense this time. Let's see, 3 months pass per second. But I see the temperature seems to have settled around 320 degrees Celsius. So for now, it's actually colder than in the previous experiment. I'll hide the atmosphere and clouds. Let's look at the surface. And here we only have a little bit of water left. And what's going on at the pole? Oh, there's a little bit of water at the North Pole. Maybe at the South Pole too? Yes, there's a little bit at the South Pole as well. And here, in this crater, interesting how it moves like that. Well, I assume the water condenses instantly when this part of Mercury is turned away from the star. But the water here just vanished right before our eyes. Well, only a small amount of water remains at the planet's North Pole. Now I'll spread all the gases evenly again. And as we can see, there's so much water vapor again that the surface isn't visible. I'll hide the atmosphere and clouds and try to level the liquid. The liquid has completely disappeared everywhere. But I'll fast forward time a bit more just in case. Maybe water will condense somewhere and some bodies of water will appear, at least at the poles. Well, time has passed and the temperature basically isn't changing, staying around 320 degrees Celsius. Unfortunately, I don't see any water anywhere, but the atmosphere has remained basically dense like this. But the pressure this time is lower than in the previous experiment, and it's only 34 atmospheres, whereas you remember the pressure was higher than on Venus. And well, Mercury looks like this, losing its atmosphere. I think if we moved it further from the Sun, for example, to Venus's orbit, then maybe water could condense there and liquid water would appear on the surface. By the way, for some reason I wanted to check that. Let's move Mercury just like this to Venus's orbit, for example, right over here. And in this orbit, after fast forwarding time, the temperature dropped significantly to 187 degrees Celsius. And if we light this area up right here, we can see the North Pole, and it looks like there is liquid water there. I'm even hiding the atmosphere and clouds. And we see that water actually has the potential to condense here, and there is liquid water on one of Mercury's poles. We see the same thing in the South Pole region, and the pressure also dropped a bit. That's the result of these experiments. As you can see, water really had a big impact on these objects. An atmosphere of water vapor formed on Mercury, and real oceans even appeared on the Moon. If you liked the video, support it with a like and a detailed comment. Thank you very much.